Hello everyone. I think we are already 2 minutes early to this live stream. So we'll be starting this at exactly 9:35 p.m. in just 1 minute. So let us start with the first problem of today's contest, biweekly contest 183. I hope everyone have at least solved the first two problems. So let's start with reading the description of the problem. This is all the rough sketch of the contest. So I have tried the third problem, but I couldn't solve it. Let's go and look at the first problem first, right? So minimum swaps to make zeros to end. So let me make it here. Minimum swaps to move zeros to end. Alright. So you're given an integer array nums. In one operation, you can choose any two distinct indices I and j and swap nums of I and nums of j. So that's easy, right? So in the first question, we can swap these two numbers, nums I and nums j. We select I and j indices first. Return an integer denoting the minimum number of operations required to move all zeros to the end of the array. Excuse me. So nums is equal to 0, 1, 0, 3, 12. Let's take some of the examples so that we can understand it clearly. 0, 1, 0, 3, 12. 0, 1, 0, 1, 0, 3, 12. So this is my nums array. Now I need all the zeros to be at the end of the array. And the only operation I can do is swap. Now, let us know how many, let us think how many swaps do we need. Alright, so we have two zeros here and then here. So these two zeros should be at these two indices. The last index n-1 and n-2. These two are not zeros. So what we'll do, we'll just swap these two indices and these two indices, right? So we'll be swapping and getting the number of swaps as 2. Now let us look at the another example. Now I have 0, 1, 0, 2, 0, 1, 0, 2, right? So let us see how many swaps do we need, right? Now imagine if you see I have two zeros here and then here. Now, these two zeros should be at the end of the array, here and then here. Now, I already have a zero here and I don't need another one, right? There is no need of swapping it. So, I only need to swap it here. So, this two will be swapped. So, the number of swaps I need is one. But if you see every time I'm checking, let me tell you what I'm doing. I'm checking the total number of zeros total number of zeros in the array, and I want it at the end of the array. From the end, how many zeros are there? If if there are zeros, that no need of swapping, right? Those are not needed of swapping. Now let me tell you, I'll check how many zeros are there from the end from the end. Nothing but let us take a bigger example so that you can understand it much clearly. 1, 2, 0, 4, 1, 0, 8, 0, and 0, and then 1, 2, 3, and then it's 0, right? Now, if you see how many zeros do we have here? I hope everyone have solved at least two problems in this contest, and the third one is quite difficult. I didn't even solve the third one, but I was solving the first two problems. Now, if you see the number of zeros I have is 1, 2, 3, 4, 5. Now, let us check these needs to be swapped with the end of the array. Now, the five indices which I need to have zeros are these. This one, two, three, four, five. So if you see the total zeros are five, right? The total zeros are five. 1, 2, 3, 4, 5. The total zeros are five. Now if you see the last five indices are already having two zeros, right? That doesn't need any swap. But the remaining three, these three needs swap. So the total zeros are five. Go and count how many, go and count how many zeros are at the end, right? So total zeros minus zeros at the end. Nothing but here I have five zeros so that I went to the zeros at the end. But what if n is equal to 10? Now the index will be 9, right? The last index will be 9. And imagine total zeros I have in the array is 5. Now I need a 0 here. 1, 2, 3, 4, 5. I need to count till here, right? So the index will be 9, 9, 8, 7, 6, 5, right? So I'll be starting at I is equal to n minus 1 and I'll go till I is greater than or equal to n minus 5. N minus 5 is still 5, right? 10 minus 5 is equal to 5. So I will be greater than or equal to 10 minus 5, which is 5. So I minus minus. I will look at what are the zeros I have in this, and I'll just I'll just decrement the total zeros. That's it. So I think that's all, and I hope many of you have already solved this. This is an easy problem compared to the third one, right? Let me know how many of you have solved the third problem. I have tried the third one, but I couldn't solve it. So I think it's good if we go to the second problem. Minimum operations to make array modulo alternative, right? So let me know how many of you have were able to solve the third problem, right? Wait a second. Right now we are moving to the second problem, and if you have any doubts on the first problem, please let me know. Right, they are asking us minimum operations to make array modulo alternating. Let me tell you one thing. Let me tell you one thing. This is an easy problem if we understand the problem, right? So nums array, we are going with the nums array. Now we have even indices and also odd indices, right? Now, even indices, when nums of I at the even indices are have done the division, the modular operation, it should be x. Now, nums of I modulo k should be y. That's it. That's what they are asking us. Now let me know how can we solve this, but before going to that, we will look at the constraints where we have nums dot length is only 100 and nums of I won't be greater than 1 in 9 and k will be less than or equal to 100, right? Now even indices, the nums of I at even indices modulo k should be x, and nums of I modulo k, the indices nums of I at odd indices modulus k should be y. Now to make it, to make this, we can increment, we can in one operation, or we can say that in one operation increment a number, increment a number by 1, or you can just decrement a number by 1. Now let's take an example so that you can understand it clearly. Minimum operations to make, yes, 1428 and k is equal to 3. Let's look at an example x and y which is less than or equal to k. Right. Now let's take this 7, 2 and 10. These three nums array. Anush bro, hi. I hope you're doing great. Hello and thanks for attending this live stream. And let me know how many problems have you able to solve in this contest, biweekly contest. 183, right? 7 to 10, and let's take the k is equal to 6. Let me tell you, let me tell you the first intuition. Let me tell you the first intuition, which is tell you the first intuition, which is if I if a number something like anything like was only able to solve one problem, no problem, bro. I think you are a beginner. And let me know how many months have you been doing this contest, right? Doing this contest. Let me tell you, if I divide anything with k, let's take a number, a num. If it is divided by k, the result, the result will not will not exceed, will always be less than k. We can say like that. Result will always be less than k. Let us take an example. If I have 53 and k is something like 5, k is 5. Now, if you see, if I divide 53 with 5, 5 tens 50 and I have 3, which is less than 5, right? Which is k. So every number, I don't care which number it is. Num mod k will always give a result. A result. Anuj, I started recently, I guess 2 weeks, had a gap of 3 years. Yes, bro. Okay. May I know which year are you studying, or you're already placed in a company, or you're a graduate, right? So you said you have been solving it from 3 years. That's good, right? But you had a gap of 3 years. Okay, 3 years. Right? It's good that you have came back to this contest, right? So no matter what the number is, the result will be less than k. That's a simple math. If it is like even 55, 55 mod 5 will be 0, right? Which is already lesser than 5. I'm placed. Okay. Anuj, bro, thanks. Thanks for attending this live session, right? Want to switch again in next 2 months. That's good, bro. Let me know, is it a service-based or a product-based company which you are working in, right? So that's the first thing. Result will be always less than or equal to k. And we are saying that nums of I mod k should be equal to x if I is even. And at the same time, we are also asked nums of I mod k is equal to y if I is odd, right? Uh, and I think there is this US startup, right? Therefore, thank you for letting us know. And we'll be having the tomorrow's weekly contest live discussion or live explanation. So, what every viewer should I'm requesting every viewer of this live stream to attend the tomorrow's LeetCode weekly contest, right? So that we can go with 1,000 subscribers soon. What about you, brother? Bro, I'm working as an intern in a company in Hyderabad. I'm from Hyderabad, right? So it is US startup. I think you are doing it as what do we call it? Remote job manager, right? So I hope everyone is clear with this thing. Nums of I mod k should be x if I is even. Nums of I mod k should be y if I is odd. Now, one thing which I come to the conclusion is if I divide any number with k, it will be less than k. So x and y will also be less than k, which is already given. But k will be k, as they said, is less than or equal to 100. Now let me tell you one thing. Even if it is like not that much or not 100, let me tell you one thing. What is the maximum reminder which you can get, right? So as it is less than k, I'm telling you that for just like fix x and y. Yes, bro, remote job, that's good to know, Anish, bro. And let me give you my LinkedIn. Let us both of us connect. My LinkedIn is Ragipani Sai Sidhu, or I'll give you the link in the live chat itself. Let us also solve uh, parallelly. Fix x and y. I can go with x is equal to 0 and then y is equal to 0. X is equal to 1, x is equal to 2, and so on till k. Y is equal to 1, y is equal to 2, and till k. So x is equal to 0, y is equal to 0. That would be a pair. X is equal to 0, y is equal to 1. That would be a pair. X1, y0, x1, y2, x1, y1. Something like x and y. Try every pair. Try every pair. Right? So I think till here uh, you got it right. We have to try every pair, x and y pairs. By then, let me, oh, sorry, I have mistook linkedin.com/in/r size, right? So anyone wants to connect to me with the LinkedIn, and I also have uh, my Instagram, right? I think uh, without wasting our time, let's start solving the second problem. Right? We are halfway there. Letting, we are just going with every pair. That's the first intuition. Go with every pair, x and y pair. Now, now our target is for I is equal to 0, I is less than k. Sorry, x is equal to 0, x is less than k, x plus plus. For y is equal to 0, y is less than k, y plus plus. Now, one thing Anish bro, thank you. Thank you for subscribing to our channel. So, for x is equal to 0, x is less than k, y is equal to 0, y is less than k, we have x and y. Let us take 53 mod 5, which is just giving us 3 as the answer, right? Now, what if I have x is equal to 2? Just like I need the target is equal to 2, right? Now, what I have here is 5, which is nothing but k. K is equal to 5. What should I add? What should I add to 53 so that I would get the target which I am looking for? What should I add? 53 plus what is that? What should we place as remaining? Let's take that as remaining, all right? So if it is done the modulo with 5, it should give us it should give us 2 as what do you say 2 as the answer. So 55 plus, if I just do 4, 53 plus 4, which is nothing but 57 mod 5, will give us what 53 is giving. 53 is just giving me 3. Actually, it needs to give me 2, right? So I will add 4 to the number. Now, what should I remove from 53 so that I can get 2? Let me tell you, if I remove just one, 53 minus extra, just let us take it as extra, 53 minus 5, which will give us 2 as the remainder, right? So if I just remove 53 minus 1, which is nothing but 52, mod 5 will give us 2, right? So from 4 and 1, I will choose 1. That's it, right? Anuj Pro, thanks. Let's connect with the LinkedIn. Okay. So if I if I add 4 or just have 4 operations, then I'll be having 2 as the remainder. If I just remove 1, I'll be having 2. From this, either 4 operations or 1 operation. I'll choose 1 operation because we are asked with minimum operations, right? So I hope we are clear with this. Now let's go again. Let's go again. Here, how do you know that 4 should be added? 4 should be added so that it will give us 5. Sorry, it will give us 2 as the remainder. How do you know? We need to remove 1 so that we would know that 2 will be the remainder. That's the thing which we need to go forward, looking forward. How do we know the number which needs to be added? How do we know the number which needs to be deleted? If you see, let us take the target which is 2. Now, if you see, I have a number, right? 1 second. 1 second. Uh, let me tell you one formula so that you can understand it easily. Kadiam. Okay. I think you are from Yesuraju Kadiam. Just now have some me follow request. I think you are following me from YouTube, bro. If so, please let me know in the live chat. Let me take an example so that we can easily understand it. But wait a second. 7, 2, and 10. 7, 7, 2, 10. This is the nums I have, and k is equal to 6. Now, nums of I mod k. So we need nums of I mod k. What's the remainder of this? So we will convert one thing. We have num, now we have mod 6, right? So what are the nums we are doing? 7, 2, and then 10. So nums of I mod k, 7 mod k, nothing but 7 mod 6 will give us 1. 2 mod 6 will give us 2. 10 mod 6, 6, 1, 6, and the remainder is 4. So our array will become 1, 2, and then 4. Now the thing is, we need one target conversion, right? So make all values target is equal to 5, right? Now let me tell you, I'm choosing a target of 5 as something like we are taking every pair, right? Every pair. So x goes from 0 to 6, y goes from 0 to 6. So let us take the target as 5, right? Now, as I'm taking the target as 5, so excuse me, so I need +1 or -1 steps to turn this each number into 5 mod 6 circle, right? Let me tell you. So 0, 1, 2, 3, 4, 5, and then 0, right? So how can we how can we compute for the each element, right? So I have in the clockwise direction 1, 2, and then 3, and then 4, and then 5, which is nothing but 4 steps, right? Now from the counterclockwise 1, and then 0, and then 5, which is nothing but 2 steps, right? Now the best from these 4 steps and 2 steps will be just 2 steps, right? So from going from 1, and then 2, and then 3, 4, 5, which will take us 4 steps, instead I would solve it in just 2 steps, right? Now this will be for 1. This will be for 1. Let me tell you, for 1, I'm saying that to get to the target of 5, modulo 5, I have to go from 1, and then 2, and then 3, and then 4, and then 5, which will take us 4 steps. But this is in clockwise. I'm just going in the increment approach. if I go decrement it 1 and then 0 and then 5, which is nothing but two steps, excuse me. Now, let us take the second number, which is 2. Now, from this, 2 to 5 will be 2 and then 3 and then 4 and then 5, which is nothing but 1, 2 and then 3, which is nothing but 3 steps. Now, if you see, if I go in counterclockwise, 2 to 1 and then 1 to 0, then to 5, which will give me 3 steps, right? From both of them, I have the same number, 3 and 3, so 3 will be selected, right? Now, if you see, I have the another number where the 4, right? So the next number is 4. Now, from 4 to 5, only one step. But if I go from 4, then 3, and then 2, and then 1, then 0, and then 5, how many steps? 1, 2, 3, 4, 5, which is giving me 5 steps. Here, 1 will be selected, right? So that's how I go with every element. So I hope it's clear for you. And if you have any doubts, please let me know. Right? There is only small code part. Now, how can we get it? Right? So total cost is if target is equal to 5. Now, 2 plus 3 plus 1 will give me 6 operations for this nums 7 to 10 and k is equal to 6. Now the real idea of the problem is not we don't know target. We try all targets x and y going from the loop as I said here x is equal to 0 to 6 y is equal to 0 to 6. I'll take every pair x and y pair. Now each number will sit in a circuit. Let me tell you how. Let me tell you 0, 1, 2, 3, 4, 5, which is nothing but a loop, right? Now, if you seek to change a number, you either go forward or backward, right? But from these two, we need to choose the shorter or the minimum operation, shorter or the minimum operations, right? Now, if I have nums and all, I have this, I have this k minus 1 till k minus 1, right? So we will be having x is equal to 1, y is equal to 2. We'll be having x is equal to 0 to x is less than k, y is equal to 0 to y is less than k, and the number of operations is 0. Now, R is equal to nums of I mod k, the current remainder. Now, target minus R. I have the target which is to increment if the target is 5 and the current remainder is 2. 5 minus 2 is 3. So, what if it is not 3 instead? It is something like going in negative. So, that's why to not go in negative values, we will add modulo operation, nothing but adding k and then uh, taking the modulo of k. So I think there is a name for this, right? So instead of going into the negative values, we will use this modulo operation, right? So I think most of you have already solved this second problem, but the problem with this contest is with the third one. I have been looking at this. Wait a second. Okay, okay, right. I think now it is visible. There is no double screen right of my. video. Target minus r plus k mod k. R minus target plus k. Nothing but if you see 2 minus 5 will give us 3. Let me explain you this model operation. I need 2 to 5, so 2 to 3, 3 to 4, 4 to 5. It is nothing but 3 operation, 5 minus 2 is 3. Now 2 to 1, 1 to 0, 0 to, sorry, 2 to 1 to 0, and then 1, 2, 3, 4, and then 5. I hope it's correct. 2 and then 1 and then 0. 1, 2, 3, 4, 5. No, that's 2, 3, 4, 5. Right? Let me go with the reverse one. 2, 1, 0, and then 5. Sorry, that's why I got this. Right? 2, 1, 0, and then 5. Right? So here it is taking 3 operations. Here also it is taking 3 operations. But if I do 2 minus 5, it's nothing but minus 3. So to not get minus 3 mod k, which might be an error. So let us take 4 to 5, right? Instead of 2 to 5, 4 to 5. So 4 to 5, which is nothing but increment. Now for decrement, 4, 3, 2, 1, 0, and then 5. So 1, 2, 3, 4, 5 operations, right? So if I just do 4 minus 5, which is nothing but minus 1 mod, what is the k? K, let's take the k as 6. That's why we are getting 5, right? So minus 1 mod 6 will might give me minus 1, but that's wrong, right? So 4 minus 1, what I'll do, I'll just add with 6. Now what I'll get, 4 minus 1 is minus 1 plus 6. 6 minus 1 is 5. 5 mod 6 will give us 5. That's what the number of operations we are doing here. 1, 2, 3, 4, 5, right? I hope it's clear for you, and we will be going to the next problem. But before that, please let me know if you have any doubts regarding the first and the second problem. And let me tell you this third problem I haven't solved till now. And if you have solved it, please let me know, or let me have any hint. And also, we'll be discussing this problem instead of just solving like the first and the second problem, right? So, might be, wait a second, let me move the mobile. Okay. Instead of solving this, we'll be discussing about the problem. Maximum path intersection sum in a grid. That's a good problem, and I have gone to some intuition, and let me know if my intuition is wrong. Sorry. Let me know if my intuition is wrong. So we are given with a grid. Let me take two colors. The first color will be this, the blue color. So this blue color starts at this point and can go to the right and can go to the bottom. There is another path. This way I can go to the right or I can go to the top. Let me tell you one thing. Let me tell you one thing. We are asked with whatever the matching, how can I say, whatever the matching, this will go till here, and this will go till here, like this, just like this, the final point. Now, I need this sum. I need this sum, the intersection sum, the intersection sum, intersection sum. That should be maximum, right? That should be maximum, and that should be the intersection sum. From the path A, let us name it as A. Let us name it as A. Let us name this orange one as B. So the those cells where I have A and also B, I need those cells, right? So those cells I need, and that needs to be maximum, not only to be something random, but that should be maximum. One thing. Let me tell you one thing. Instead, uh, wait a second, then wait a second. Okay, instead of looking at this problem, looking at this problem as two paths going from the start to the end, instead of looking like that, let us look it in a different way, where where the paths can meet and where they cannot meet, where they cannot meet. Let me tell you one thing. Let us take a 4 by 4. 4 by 4 will be better, I think. 5 by 5. One, two, three, 4, and 5. Right now, I'm telling you that if I go from here and then go from here, or if I go from here and sorry, here and then here, let me tell you one thing. I can get only one cell as what do you say? As intersection, right? One cell as intersection, right? Now, this is one possibility. Let me take let me take this only this one, only this one for several times so that we can understand we can understand what they are asking us. Okay, that's quite more examples. Now I'm saying you that I can get here like this and then here, and I also can get like this. So this is a valid path, right? Here there is only one intersection, only one intersection. Only one cell can be an intersection for both the path A and B. Now let me take like this. Let me take like this, and let me take, there are only two cells. There are only two cells where both of them have met. Now let me tell you, there can be two cells, right? But but can we get like this? Let us see. Let me let me have let me have an assumption that I have something like L as the intersection, right? Now, if you see, the blue part can go like this, the blue part can go like this, or part A can go like this, but but this one can go till here, and it should not go here, but because it is not the part where we have we have the intersection. Now, will it come back? No. Why? Because it cannot go to the bottom. It can go either to the top or to the right. So it's clear that I cannot get an L-shaped intersection cells. Try it out with anything. Or let's look at another thing like this, right? So imagine we are trying to create an L like this, right? Now here I will have this orange part. Now what about this part? This cannot go to the left, right? And it will be stuck here itself. This cannot go to the left. No, it is not possible. Let me cancel it out. It cannot go to the left part. So it is clear our intersection section cells can't make an L shape. They either make they either make they not either they can only make a straight line. That's clear for now. That's clear for now. But let me tell you another thing. We have given with an example that we are given with this one and this one got, and we have like this something like this example. Now our path we follows this path, right? Now the intersection points are these two, right? Only these two. And okay, we have only 2 points. That's good. That's that's good. Okay. Now what next? What next? Let me tell you another thing. If I have if I have something like this and then like this, okay. Now I can go if I want to meet this, then either if I want to go at this point, either I have to go top or I have to go right. There is no other option. Let me tell you another thing. Let me tell you another thing. Imagine they are meeting at this point, at this point. Now, the intersection, if I have to definitely go to this point, either I have to go right or I have to go top. So, so what I am saying is concluding that from the edges. So if I select a cell from adjacent or cell from the edge, then I need to expand with other cells. That's good to know. And I am saying that I need to definitely expand to the other cells. You cannot you cannot go with only one cell at the edge. Let me write it also. You cannot have, you can't have only one intersection cell at the edge. At the edge. Now, what does this edge mean? You have to understand this cells or edges at the edge cell. So this alone, only one cell cannot be selected, and let me prove that. Now imagine our path A comes like this. Now imagine our path B comes like this. Now this should go either top or either right. If it goes to the right, it is having one more cell. If it goes to the top, it is having one more cell. So you cannot have only one cell as the intersection at the edges, but you can surely and definitely can have only one cell in the middle. That's possible. But at the edges, you cannot get only one cell as the intersection. So we have 3 points. our intersection cells can't make an L. Yes, let me write all those which we have confirmed, or what do you say this? What do you say? Like whatever it might be. Can't make L shape, L shape intersection, intersection can only make a line as intersection. These two are conformed, right? You cannot make an L shape. If not, you can try any way. I'm saying that you cannot make an L shape. If I select a cell from the edge, then I need to expand with other cells. Or simply cells at edges can't be can't be selected, only one, or or only one cell at the edge can be selected as intersection section cell. I think it's good to know these 3 points can't make L-shaped intersection, can only make line as intersection. Cells at edges can't be selected, only one. It needs some adjacent cell, either top or right, either left or bottom, whatever. It needs some adjacent adjacent cell. Let me tell you one thing. Now, now flip the problem. Just flip the problem. Flip the problem. Now, let us look at the edges. Let us look at the edges, right? So these edges can expand inwards, right? Okay, that's one good thing to know. That's one good thing to know that I can take a cell here and I will check what what is the sum I would get if I go to the left, right? So I hope you understand if I just take the sum like this. If I select these cells, okay, that's good to know. Now let me tell you another thing. Let me tell you another thing. This is one thing which we knew. Now what about those cells? As I said, you can only make a line. What if I take three adjacent cells in a column? That can be possibility. Now there is another possibility. What three cells in a column have maximum, right? These three are maximum. So I am coming to the conclusion. I'm coming to the conclusion that check inwards inward sum from every edge cell and check the check the maximum subarray sum for every row. And I think we need to exclude the edge cells for every row. Check the max subarray sum subarray sum for for every row. Every row. Exclude edge cells. Now, same thing, check the max sub array sum. What if I get like this in a line like this? Maximum sub array sum for every column. Exclude edges here too. Exclude edges. That's good to know. We have concluded three things. Inverts, every cell can go invert, and I can get maximum sub-array sum in a row excluding edges. Because these edges, if I include this edge too with the maximum sub-array sum, what goes wrong here is this one already got it with this checking invert. Including the edges, we have already done it, so why we need to do it again? So that's why I am excluding the edge cells. Excluding the edge cells. Now there is another thing. There is another thing which I have to tell you. Take this. Great. Take this. Great. Now I have checked this invert with this cell. What if I have, just tell me, what if I have a cell like this, three cells, which is giving me maximum sum. But if you see, this is also, maximum sub array sum, max sub array sum. Let me tell you, but here it should not include one cell. That's the error. That's where I got stuck in the contest. The sub array should not be of size 1. That's it. If it is not of size 1, it's it's the only thing which stopped me from executing this. I think I came to the solution, right? Maximum sub array sum, but sub array size should be greater than 1, right? The sub-array sum should be the sub-array size should be greater than 1, right? So, what is our algorithm? Just writing our algorithm. So, first thing, go to every cell, edge cell. Yes, bro, my lead code ID, maximum path intersection sum. Okay, let's. My ID is R Sai Sidhu 1106. Yes. You can also follow me in GitHub. So I've been solving this. Bro, let me know your full name. Thanks for attending our live session. We'll also have the live session tomorrow, however, weekly contest. I don't know the exact number of the contest, but we'll be having it around 9:35 as usual, right? So 9:35 to uh, something like, I don't know when it will be ending. Down our streak. Okay, bro. Thanks for thanks for your motivation. Right. So thank you. So what your streak? I am having 601 as the streak, bro. 601 days. Right. So I am been solving like around 2 years, but more than 2 years. But I have this, what is a streak of only 601 days. I have started this in September 24, 28 or 29, I think. 29 from the day I started this streak. But without late, we should were the same. Okay, bro, let me know what is your ID. Okay, even if it is good, or even if it is you are a beginner, no matter what, right? So I just want to know your lead code profile, bro. That's good. Thank you for your motivation, bro. Bro, let me know what is your name. Your name is giving me like blue, right? So, okay, go to every edge cell and get the sum inwards. So let us write a pseudo code for this, but let me write the whole algorithm, then we will go with the pseudo code. Siddhartha, okay, your name is also Siddhartha. Good, bro. My name is also Sidhu. You, Shan, Siddhartha. Siddhartha, bro, what are you doing right now? Rank 30. Good, bro. You are also level knight 2000. You are maintaining it good. Right, full set 55. Little contest. Okay, that's good, bro. Yes, your streak is also very good, bro. Ishan Siddhartha. Let me know where are you from, and you're doing only in lead code, or you are also uh, following it in where do you say code forces and also code chef. You are also following those problems and context. Please let me. And which year are you studying in, Siddhartha? Right. Okay. So one thing, go to every edge, update max or update answer. I'm from VNS. VNS, I think I have, let me search it. I have heard about this college, VNS. Start workforce and coach of recently. Okay. Gujarat University. So you are from Gujarat. Am I correct? Siddharth? Okay, code for and coach of. Yes, that's Varanasi. VNS Varanasi. Okay. I follow you on LinkedIn in I am bro. Birla Institute of Technology. Okay. You're from Birla Institute of Technology in Mesra. Okay, you are saying you are from Varanasi. Okay. Understood. Understood. Right. So VNR is our college. VNR Vignana Jyoti. So I just confused. Hyderabad, there is a college in Hyderabad, VNR Vignana Jyoti. So I just confused. Is VNS is something like so? You are from Varanasi, a great place, bro. Great place to visit. I mean, saw your stream, so thought I should drop in and connect. Yes, bro. We can connect through LinkedIn. You are also following me from LinkedIn. You can just send me, yes, yeah, send me the LinkedIn action request. Okay, that's good. How many times you have visited, that uh, places there, right? It's also my wish to go to Varanasi, Banaras, right? It is also called as Banaras. I have planned for a trip last year, but not last year. I think this February, no, last year's February. planned, but it got cancelled. Okay, okay, is it okay? Now we are updating answer every time. Now I need to take the cadence algorithm. Uh, Thanks for the stream, bro. I have to leave now. Okay, bro, Anuj, bro. And when you get up tomorrow or wake up tomorrow, please solve the third problem. And if you have knew how to solve the third problem, you can just DM me in LinkedIn. I'll reply you. Let's connect there. Yeah, bro, Banaras. It's a chill place. Yes, bro. Good night, bro. It was nice finding you. Good night, bro. Thanks for attending this live session and happy coding. We'll be continuing this live session, right? We'll be solving or at least trying to reach 75% of solving this third problem. Check the max sub array for every row, excluding excluding the edges, right? So, okay, sure, Anuj bro. Okay, happy coding and good night. Now, get max sub array sum for every row and exclude edges. Nothing but how do you get the row is having some elements. The first element and the last element will be excluded. Right? Browser storage. Okay, I need to delete some things, but let us not delete these. We'll delete, however. Let me delete all of these. Actually, I can select it like Control A, but Control this. Okay, okay, okay. I have got it. Let me select this and copy it. No, I am not getting it. Okay, okay. Do I have to, wait a second, wait a second. I got just now cells at edges one. Okay, cells at edges can be selected, but how do I delete it? However, let us go here and then delete it. Yes, we can definitely delete these and clear up our storage. This is the problem with the website of this EXCALIBRAW, right? Okay. I I should have deleted it. I should have deleted it when I was solving the contest itself. I know it's wasting most of your time, but please make sure you take a little breaks in between of 4 to 5 minutes. Then let us join the live stream again, right? So, so I think that's enough for now. For now, I think that's enough right now. Let's go back. Let's go back to the problem. Okay, let's go back here. Okay, I think this can also be deleted. Yes. Okay, sure. Let us go. Okay, I think I'm wasting much of the time, but let us not. Uh, X is equal to 0, X is equal to Y. Okay, now, now get max sum for every row, exclude edges, get max sub array sum for every row, exclude edges. Do the same thing here. Get max sub array sum for every column, every column. Here also exclude edges as the same thing. Just the first element and the last element will be excluded out from the array. Go to every edge cell and get the sum invert in update answer. How do I write this? But before that, do I have anything? Yes, this one. Max sub array sum, but sub array size should be greater than or equal to 1. Go to four edges, four edges. Get max sub array sum, but the sub array size, the sub array size should be greater than 1, right? Let us write these, go to every edge cell and get the sum inverts update answer. So answer will be 0 initially. So I need to start with every edge cell. So how do I get every edge cell? So let us concentrate on this part. Let me write that part. So for what is the, let me have the row. Row is already 0, right? I is equal to 0. For j is equal to 1, j is less than how many columns I have? M. M columns, n rows. N rows. So j is less than n minus 1, j plus plus. Sorry. Yeah. J is less than n minus 1, j plus plus. This is m, this is n. So I have every element. I have every element. Now I'll go to the rows, right? The rows. How can we go? I think we can go with k. Yes. So for j is equal to I, j is less than n minus 1 is the is the it's a place j is equal to 1, j is less than n minus 1. It's nothing but I'm uh, I'm looking at this traversal. Now what about this traversal? For k is equal to 1, k is less than m. Yes, we can say less than m, but can we get it like the whole line or whole column? Yes, definitely. So k is equal to 1, k is less than m, k plus plus, but here the sum is equal to grid of what is I? I is the row. What is this? J? J is equal to 1. So yes, we have the columns. Now sum plus is equal to grid of what is the row? If you see the row is k is equal to 1, k is less than m. That's how I am traversing. So the row is k. And what about the column? Column is fixed. Nothing but j. J is the column which is fixed, right? So if I think I have to write it clearly. So I is equal to 0. For j is equal to 1, j is less than n minus 1, j plus plus. Here sum is equal to grid of I and then j. Now for k is equal to 1, k is less than m, k plus plus. Sum plus is equal to grid of k and then j. Now answer will be just updated max of answer comma sum. That's just for this one. For only that one we have to like 2 to 3 minutes, but let us see how much time will it take for this one. For this one. So one thing I need to fix is the column. Column is nothing but the j, which is nothing but n minus 1, right? Column is n minus 1. So the rows are changing, right? The rows are just changing. The rows are changing, right? Okay. So I is equal to 1. I is less than m minus 1, right? So I plus plus, just like that. Here, answer now. J is fixed. J is equal to n minus 1. For I is equal to 1, I is less than m minus 1, right? M minus 1 and I plus plus. I'm pointing here, 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 here. Right now the sum will be the element at that point. So the sum will be grid of what is I already have been in the correct way. I will So the first one will be always the row, the second one will be always the column is j is n minus 1. Now if you see, what about k will be starting at this point, nothing but n minus 2 and going till greater than or equal to 0. So k will be starting from the number n minus 2 and k will be greater than or equal to 0, k minus minus, right? So I will add this element. If you see, the column has been changing. We are changing the column, right? We are changing the column n minus 2, n minus 3, and so on. So the columns are changing, and the row which I am having, the sum plus is equal to grid of what is the row? The row is the same row, right? The row is I, and the column is the one which is changing, and the answer will be updated as max of answer, comma, sum, right? Okay, clear. Now let us look at the border, these edges. Now this is M, this is N. Now I'll start from I's columns. So the row which we need to fix is I. So the I will be M minus 1. I will be M minus 1, right? I will be M minus 1. Now for J, which is nothing but the column, J is equal to 1, J is less than N minus 1, J plus plus. Now the sum will be grid of I and then J. I and then J. Now Now I can go like to the top. I should go to the top. So k is equal to where I start this m minus 2. M minus 2. It's not something. Yes. So m minus 2. I'm starting at m minus 2 and going till m minus 2 and going till k greater than or equal to 0 and k minus minus. If you see, this is the row which is changing, and the column is still the same, which is J, right? So the sum plus is equal to grid of what is changing? The row is changing and the column is same J. So answer is equal to maximum of answer comma sum. That's it. Now let us look at how we can go with the edge. The left edge is all. So these are nothing but m and these n, right? So I'll start with which is fixed here. The column is fixed. So column, we'll use column as j. J is equal to 0. For I is equal to 1, I is less than n, sorry, m minus 1. M minus 1, I plus plus. Now sum is equal to grid of the I is the row and the j is the column. So ij this, I have the sum. Now I need to have the k starting from here, starting from 1. So for k is equal to 1, k is less than n, right? K is less than n, k plus plus, I'll have sum plus is equal to the grid is having the same row, which is nothing but I. And I have the column as k, and the answer is equal to of maximum of answer comma sum. That's it, right? So, okay. For now, this is the one thing which we have done. Go to every Excel and get the sum, invert, and update answer. I have done that updating answer. Get max sub array for every row, exclude edges. So this is part one. If I say like just this is part one. Now what is the part two? Part two is nothing but get max sub array for rows and columns, exclude edge cells, right? So so what I want to do is for every row, I think I have got it in the, no, I haven't submitted anything, but it's okay. For every row, for I think would it would work, right? Okay. Let me tell you one thing. Let me tell you one thing. I'll get the row into cadence algorithm, which takes the array and returns max sub array sum. Now, when I call the cadence algorithm, I'll tell you how I'll call the cadence algorithm. For auto row in grid, I'll just call answer as max of answer and cadence row. Now in this, it will erase first and last elements. Same with the columns. For I is equal to 0, I is less than n, I plus plus, vector of int array. For j is equal to 0, j, wait, let us not take I for rows. J is equal to 0, j is less than n, j plus plus, j plus plus, right? So for I is equal to 0, I is less than m, I plus plus array. Here we need to create an array, vector of int array, array dot push back grid of I j. That's it. That's how we call it. So this is the part two. Get max subarray sum, but the subarray size should be greater than 1. I think we need to find out how would we get the max subarray sum with the size greater than 1. Caden 2 with an array we will call, which returns max subarray sum with subarray size subarray size greater than 1. Return the max subarray sum with subarray size greater than 1. That's caden 2 will do. But how do you go and get for every edge, right? So for every edge, how do you get every edge? That's the first thing. That's the first thing, right? So if I am having an edge, so let us take the left edge. The left edge. This is M and this is N. So for let's take let's take J is equal to 0. That's the column. For I is equal to 0, I is less than M, I plus plus. So let's take an array, vector of int array dot pushback, array dot pushback, grid of I j, right? Now I need this top one. So the I will be 0 for j is equal to 0, j is less than n, j plus plus array dot pushback. But before going to top, we need to get the answer. Answer is equal to max of answer comma caden2 of array. Then clean the array dot clean, just array dot clean. So array dot pushback grid of I and then j. So I is equal to 0, j is plus equal to okay. Then answer again max of answer comma caden2 of array dot clean. Now again right. So how do I get the right? So this is M. Sorry. This is M and this is N. Now I have the J is equal to N minus 1. For I is equal to 0, I is less than M, I plus plus array dot pushback grid of I and then J. Now that's it, and the answer is equal to max of answer comma caden2. Hardik bro, I think you have been following me from. I know I'm guessing like that. Hardik Rida. I have also got the same comment from the same ID. Give and also identify. So I give as a give and also identify same edge case of boundary. Need at least two element, but could not able to think how to implement boundary case in code. Yes. That's the third one which stopped me. Bro, you have my LinkedIn. I think so. I think so. If not, you have the LinkedIn there. You can connect me. You can connect me with there and you can send the code at the time which you have implemented and let us just cross check whether we are going with the same approach for the first two steps, right? For the first two steps, the edges inverts and also the cadence, all of that. The maximum sub array sum for every row or every column. Hardik Pro. So you can just send me the request from LinkedIn, and then just message me or just give me a screenshot or a picture, right? So answer will be updated and answer dot clean again. And now what about the bottom is the one thing which we have left. Where? Yes, bottom. Here N and here M. Yes. Thank you, bro. For so if you see, I need to initialize what is your row is initialized to for I is equal to M minus 1 for J is equal to 0, J is less than NJ plus array dot pushback grid of IJ. Now answer will be max of answer comma cadan 2 of array cadan 2 cadan 2 of array answer dot clean, and we can return the answer at the end. I need to make this clear for you. This is not an easy problem, right? Okay, so let us solve this. Let us at least try solving this. Let me write int answer is equal to minus 1 e9. That I'm thinking like in min or whatever it is. Int I is equal to 0 for int. Let me do one thing here. Okay, yes, I'm just typing the code. In j is equal to 1, j is less than n minus 1, j plus plus, we need to initialize m and n. So m is the number of rows. Int m is equal to grid dot size, and n is equal to grid of 0 dot size. Now int sum is equal to grid of I j for int k is equal to 1, k is less than m, k plus plus sum plus is equal to grid of k j, and then answer is equal to max of answer comma sum. Int j is equal to n minus 1 for int I is equal to 1, I is less than m minus 1, I plus plus. So int sum is equal to grid of ij. Now for int k is equal to n minus 2 and k is greater than 0, k minus sum plus is equal to grid of I k. Answer is equal to max of answer comma sum, right? Okay. Now I is equal to m minus 1. I is equal to m minus 1. Now for int j is equal to 1, j is less than n minus 1, j plus plus sum int sum is equal to grid of I and then j for int k is equal to n minus 2, k is greater than or is equal to 0, k minus minus. Now sum plus is equal to grid of k and then j. Hardik bro, please let me know, are we going in the right direction for the third problem, right? So this is the step one we are doing. Now answer is equal to max of answer comma sum. Wait a second. One thing we are not doing is to make the sum, no, I think there is no need of again going with the sum making it as 0 because it is local. However, it is inside this for loop. Outside of this for loop, we don't know what the code doesn't know what sum even means. And we are initializing the sum again and again. So I hope you got it. For int I is equal to 1, I is less than m minus 1, I plus plus. Wait, scale I plus plus int sum is equal to grid of I j for int k is equal to 1 k is less than n k plus plus sum plus is equal to grid of I k, then answer is equal to max of answer comma sum. So we'll be returning the answer at the end, but get max sub array for rows and columns. Exclude edge cells. So we'll be calling the cadence algorithm, but for auto row in grid answer is equal to max of answer comma cadence of row, right? For in j is equal to 0 j is equal to 0 j is less than j plus plus vector of int array for int I is equal to 0, I is equal to 0, I is less than and I plus plus heartbeat kotari. Okay, you are also from Hyderabad. Okay, that's good to know, bro. Hardik, bro. Okay, you are doing one take. Yeah. Okay, that's good to know. Right. So now I will have array dot pushback. Sorry, pushback grid of I and then j. Right. Now caden 2, but before that, I think we haven't updated the answer in the pseudocode, but answer is equal to max of answer comma caden of array. Right? Okay. Now comes the caden 2, but before that, let's get the caden algorithm. Caden algorithm. Yes, maximum. I think I already solved this maximum subarray. Solved, yes. Answer is yes. Yes, you need to change the name to caden. Instead of using nums, can I use but let's see whether if it returns any error or not. Let me know, have anyone solved a problem where we need the maximum sub-array sum, but the sub-array size should be greater than what, right? Please let me know in the comment section, in the live chat. And also, I haven't asked you till now in this live session, anyone who is attending my live session, please do subscribe to our channel. Yes, from 979 we have went to 5 subscribers more, right? 5 subscribers more, and we went with 984. It's just 16 more subscribers. We'll be hitting 1,000 subscribers, right? I'm also planning to get it done by this month of May, right? It's just how many days? Only 7 or 8 days, right? Okay, okay, okay. I got it. One cadence algorithm, but I have to go with the cadence 2 algorithm. But let me tell you, from 935 to 11:15. I haven't took any break from 1 hour 41 minutes in this live stream. So requesting you everyone will be also having a weekly contest tomorrow, Sunday at 8 a.m. Everyone who is attending this live stream, please attend, participate in that weekly contest tomorrow, and also attend our live stream, which will be going to held at 9:35 a.m. at that time, the 5 minutes after the contest ends, right? In the As I said, I'll be erasing the first element and also the last element, right? Nums dot popback, nums, nums dot popback, and nums dot erase the starting index which you want to erase and the number of elements you want to erase from that uh, index, right? I hope we can hit 1000 subscribers before this live stream ends. So you'll be having more content, not only specific to the tech or this coding. We'll be having much more, and even want to build this channel through many other things. It might be vlogging or traveling or it might be anything, but it won't be only concerned to coding. And let me know in the live chat if anyone know how we can get the maximum subarray sum, so that the number of the size of the subarray will be greater than 1. The subarray size should be greater than 1, right? So please let me know and let others also know, right? We just need we just need only 16 subscribers so we can hit 1000 subscribers. Let me write the CADAN2 algorithm, right? So in CADAN2 vector of int nums here, int n is equal to nums dot size is n will not be less than 2. What if what if n is less than 2? But I know, I'm thinking like the concept won't be like that. M and N will be more than 2, however. Okay, okay, that's a good thing. Now we'll start int current is equal to nums of 0 plus nums of 1. Now int answer is equal to current. Now for I is equal to 2, for int I is equal to 2, I is less than and I plus plus. Current is equal to max of current plus nums of I, or nums of I minus nums of I minus 1 plus nums of I. That's just an current algorithm, but the size should be greater than 1. Answer is equal to max of answer comma current. Right? Return the answer at that. So no need to why that's a mistake. Okay, let's go to the next, the last thing, the Cadan 2. Cadan 2. Okay, we have wrote it here. J is equal to 0 for int I is equal to 0, I is less than mi plus plus. Now we'll be having a vector of int arr array dot pushback array dot pushback grade of I and then j, right? Now answer will be max of answer comma cadan 2 of array. So that's the same, but instead of cadan we have cadan 2, cadan 2 array dot clear. Now I is equal to 0 for j is equal to 0, j is less than n, j plus plus array dot pushback grid of ij. So we'll copy this, right? Okay. Now j is equal to n minus 1 for int I is equal to y is less than, sorry, less than mi plus plus, sorry, I or j, sorry, I. So we are using m for rows, so I is equal to j. I will dot push back rid of I and then j. Now the same thing again. Now I wrote clear I is equal to n minus 1 for int j is equal to 0, j is less than n, j plus plus array dot push back rid of ij, right? So the same thing again. I think this line we don't need, but let us see. Clear. Okay, let's how many subscribers do we got? We just need only 16 subscribers. Maximum subarray, okay, maximum path intersection. Num slot, I think should be arrays, might be. Let's take nums dot arrays and nums dot begin. Okay, let's see. Oh god, minus 5, 5 minus expected 0. Okay, there is a wrong thing here. These are two algorithms. Let us hide. these two algorithms. Now where I am getting the answer as sum as 0. So C out sum is sum and L, right? So either updating here or here or here or here. Let us take sum here in sum is equal to this control C. Okay, okay. Is there any way where I have initialized sum? No, never. So let us take in sum is equal to 0. Oh, okay, I think it will be working here too. I need here also. Let us take it as sum. Now sum is equal to this. Sum is equal to this. Array dot clear again. Okay, I think everyone is clear with this. Sorry, I need to initialize. Okay. Where do I get 5 as the answer? Sum is 0, sum is 5, sum is minus 5. Sum is 5. Where did I get it? If sum is equal to 5. C out 1 and L. One, let us take 2 here. 3. Let me write it here. 6. Now I have the answer again and also the sum. So I got the sum here. We'll be having 7. If I got the sum of 5 at that point, so I'm just checking where did I went wrong. Okay, then again, sorry, sorry, here I will be having 9. Then again, I have a cadence algorithm. I have, let me say it as 10. Let me run that again. Output 5 and std out 5. So, so where did I get, okay, which row? The first row. Cadence algorithm. Okay, okay. So for the first row, I'm applying the also the column. I should not apply. I have to, okay. J is equal to 1, J is less than n minus 1, then I can apply the cadence algorithm. Here also, vector of int row is equal to grid of I. Int I is equal to 0, I is less than number of rows, m I plus plus. So row is equal to grid of I, sum is equal to cadence row. I think we won't be getting a wrong answer again. We got it again. Sorry, sorry, sorry. Row I is equal to 1, I is less than m minus 1. So the last row and the first row, we are just excluding. Let me submit this. Right. God damn. Thank, thank you everyone who have been, you know, God damn. The third problem was, you know how many lines this code is? You know how many lines? 150 lines. 150 lines for the third problem of this bi-weekly contest. Right, and also that's a good thing. That's a good thing that we have solved it. Right, everyone who have attended for this live session. We started at 9:35. Yes, 9:35 to 11:33. It's already 11:33. In 2 minutes we'll be ending this live session. If you have any doubts, please let me know in the live chat. Right, so I'm seeing only 4 people here. So if you see how many lines. So for this third problem, if you see how many lines is this code, it will be okay, 150 lines of the code, right? So we'll be using cadence algorithm for 2 times. One is the normal cadence algorithm where we get the maximum subarrangement, right? But here the cadence 2 we wrote it just because there will be these edges. We have the I have the whole explanation in the live session, but we need the edges should not be having only one element or only one cell as only one cell as okay light uh, only రెండు ఉంచుదు So if you look at the third problem of today's biweekly contest, right? So we are having like how many lines is this? It's just 150 lines if you see here, right? So some of the lines are okay. They are just the comments, right? If you also exclude like 10 lines, it's just 140 lines of the code. But the major thing here is you can use the cadence algorithm, the maximum subarray sum, just the maximum subarray sum. And here cadence too. Why? Because we need how can I say, we need the subarray sum of an array, but the subarray size should be greater than 1. So that's how we made it. And thanks everyone for attending this live session. And let me know, this probably have been like one and of hour, like 90 minutes, more than like 90 minutes, around 90 minutes to solve this, only this problem, and also explaining and solving this problem. So thank you everyone for attending this lesson. Right, so we'll be ending this in just 4 minutes at 11:40 exactly. We'll be ending this lesson at 11:40. Right, so everyone who haven't subscribed to our channel, please do subscribe. And we'll be having another live session tomorrow at sharp 9:35 a.m. after just 5 minutes of the weekly contest. There will be tomorrow's weekly contest, however. So you can also follow me in LinkedIn. Right, I have also given you the LinkedIn link to my profile, so you can follow me there. So if you have any doubts, please let me know. It's just 3 minutes away to end this lesson. Even if it's the third or first or second problem, don't hesitate to ask your doubt. From 4,000 submissions, only 1,000 submissions have been. Users accepted, total accepted. Okay, I don't know what is this, but it's like, let's go with the lead code. Maximum path intersection sum. Maximum path intersection sum in a grid. Okay, 398. Let me know what's the acceptance rate. 14%. If you see the acceptance rate is like 1 in 10 who are able to solve this problem. So it's almost and already. 11:40 p.m. So thank you everyone for attending this live session. Meet you tomorrow again at sharp 9:35 for LeetCode Weekly Contest.